Yes, so this is the first problem of today's contest. And in this problem, we are given that we are given with three non-negative integers n, k, and x, and we have to find the maximum possible sum of elements in an array consisting of non-negative integers which has n elements, and its max is equals to k, and all the elements do not exceed the value x. So if first of all, if there is no such array x, then like there is no such array possible, then we'll output -1. Otherwise, if there are arrays possible which satisfies these conditions, then we need to output the maximum sum that is possible for those sub arrays. So basically, everybody here knows what max is, right? Max is the minimum excluded integers, such that if we have integers like this, the minimum excluded integer is 0. 0 is not included in this, right? So basically, max is minimum excluded non-negative integer. So let me explain this here. So first of all, how many people were able to solve this problem during the contest? Okay. Okay. So majority of the people were able to solve this problem anyway. So in this problem, see, the value shouldn't exceed x, and the max should be, first of all, max should be equals to k. So there are two things. See, if k is more than n, then this is never possible, because if max of n integers cannot be more than n. See, what is the maximum possible max for n integers? It's n itself. Why? Because you can have integers like 0, 1, 2, all the way up till n-1. These are n integers, and the max of these is n. So there is no way that the max of n integers is more than n. So if in case you are given k more than n, then you'll simply output -1. Is this thing clear? Yes, no?
Yes, sir.
And the second thing is, if the maximum integer itself, see, the values cannot be more than x, but if x is less than x plus 1 is less than max. So what does this mean? You were never able to write this x plus 1 itself, right? Why? Because each and every number is less than or equals to x in your array. So if this number was not in the array, then how can max be more than this number? So that's why in this case also you'll output -1. In all the other cases, what we can do, see, let's assume like currently we have some current value starting from 0. We'll keep adding this value to our sum, and we'll do this iteration n times. We just need to check for two things. First, if the current value is equals to max, we'll simply skip this value. We'll make this current as current plus 1. Otherwise, now we will check if current is more than x, then we will make our current as x. And one more thing, finally, after this also, if still current is equals to max, then what does this mean? Current is still equals to max. This means x and max are equal. So current cannot be equals to max, in this case x also. So we'll make current as max or x minus 1. So once these three things are done, we can simply add this current value to our sum, and we will do this n minus times, n times. We will do this n times. Is it clear? We are trying to first get to the max value, and then we are trying to add the maximum value always. Is it okay? Yes, no. Is anyone having any doubt in this? If no, I'll show you the code. Like, this problem just seems to be hard, like the way I'm explaining this, but if you think about it logically, it's very simple. Just as like there is no there is no algorithm, no observation, nothing. It's just implementation. So there are, first I'm taking n, k, and the maximum value. Mx is the maximum value. as input. If k is more than n or k is more than maximum value plus 1, I'll output -1. Otherwise, I'll start from 0. This is my current value x. Don't get confused with this x. This is not the x that is given to us in the input. This is that. Like, this is the maximum value. So I'll start from 0, and this is the final sum, maximum sum of the array elements. So I'll iterate n times, and if my current x is equals to k, that is the current element is now itself equals to max. So see, what did I say? If current element is actually equals to max, then I have already achieved the max value. Instead of doing current plus 1, I can simply give this as max. Why? Because see, 1, 2, 3 is missing. So after 3, even if I have 4 or if I have 10, the max will be 3 only, right? So update, like the next element can be the maximum possible, which is x or mx, right? So this is what I've done. If I have achieved the max, I'll simply make x as mx. Otherwise, if x is more than mx, I'll update it again to mx. Otherwise, if my value is more than, like, after these two operations, if my x is still equals to k, that means x and mx were equal, I'll decrease my x by 1. I'll add this x, that is the current value, to answer. And for next operation, I'll increase this x by 1. Then I'll again check these three things. Finally, I can print my answer. So I hope this is clear. Yes, no, anything. Just write a quick yes, no, or just unmute yourself and let me know if there is any doubt. Okay, so let's go to the next problem. So this is the next problem. And in this problem, we are given that we have two arrays of integers, A1, A and A of length n, and an array B of length m. So now we can choose any element bj such that, like, j is between 1 to m, and for all elements in array A, we will perform this operation. That is, we'll take OR of ai and bj and update ai as this value, as the OR value of ai and bj. Now we can perform any number of such operations. Like, we can choose j, like any of these j, multiple times. So we don't have to do this operation only once. We can do it any number of times. Now, after all the operations, the value of x will be like the XOR of each and every element in array A. So we have to find what is the minimum and the maximum value of x that could be obtained after performing these operations. So how many people were able to solve this problem? Yes, no, anything? Okay. So first of all, tell me whether or not the problem statement is clear or not. Is anyone having any doubt in the problem statement itself? Okay, so the problem statement is clear. Now, instead of solving the problem for the general case, let's assume that n is even. That is, array A is having even number of elements, Okay. Now, let's say there are 4 elements. If you do, like, it is having some, like, this is having some, let's say this is having this as the binary representation. I'm just writing some random binary representation of these numbers. Okay. So right now, tell me, okay, instead of taking it this as this, let's take. So right now, first tell me that if you take XOR of, like, this is the highest, like, most significant bit, right? For these three numbers. Among these three numbers, this is the third, like this bit is the most significant bit. Like, so first of all, tell me right now, if I take XOR like this bit will be open in the, final XOR also, right? Yes, no, anything? Okay. So now, if you want to, first of all, let's say maximize. If you want to maximize okay, what is actually happening when you are, let's say you are picking some bj is like 111. If you're picking this value and you are taking OR operation with all of these, what will this simply do? Like this bit, after taking the OR operation, this bit will now be open in every element. This bit will be open in every element. This bit, if this was 0, these two bits basically will be open in each and every element, right? Yes, no, anything? Okay. So if these two bits will be open in every element and my n is even, finally, once I take XOR, these two bits will be closed in each and every element, right? Yes, no. Since n is even, right? So tell me one thing, is there any possible way after taking, like you can only close some bits. If n is even, you can only close some bits. Like you can unset those bits. It's never possible that after taking this bj or operation with all of these numbers, like you have to do with every number in array A, right? You cannot skip some number. So there is no possibility that after, if n is even, you take OR operations with each of these, and finally there is some extra bit set, finally extra bit open, which was not set initially. By initially I mean if you hadn't taken any operations, if you just find the XOR of initial array which is given to you in input. Is this thing making sense? Yes, no? Is See, if n is even, and you take OR with any bj, let's say bj is having some bits open, finally the bits that were open in bj will be closed in, like either they were earlier closed, like you can find the initial XOR. Initial XOR of this is nothing but 1, 0, 1. This is the final XOR, right? If you take XOR of these four elements, right? Yes, no, anything? Okay. So if I take like OR operation with this element, I do OR operation with this thing for each of these elements, I do this, then finally I will definitely know that the final XOR will have the first two bits closed, irrespective of what they were, like whether they were open or closed in the initial XOR, right? So in n, if n is even, I can only, by doing some OR operations, I can only close some bits. And to be precise, which bits can I close? I can close all those bits which are open in bj, right? I can never open some bits in final XOR. I can, if this was the initial XOR, I closed this first bit and the second bit. Second bit was initially also closed, but still it's closed because I took this as the bj. So any element you choose, all those bits will be open in all the elements. And since n is even, that particular bit will now come like even number of times in the XOR operations. So finally it will be closed only. So that's why you can only close bits. So first of all, what is the maximum value when n is even? What is the maximum value that you can get? Can anyone tell me? What is the maximum value? Yes, it's the initial XOR only. So if n is even, the maximum value that you can get is the initial XOR itself. Initial XOR. And now how to find the minimum value? See, for minimum value, like I said, these are the elements. You just need to find whether this bit can be closed or not. How to find whether this bit can be closed? There are two things. First, just check. Okay, instead of finding whether this bit can be closed, just find whether this bit will always be open. When will this bit always be open? When you cannot close this bit by taking some OR operations. So when can you not close this bit? When none of the none of the elements in array B is having an element which is having this bit open, this set bit. If none of the elements in array B have this set bit open, this simply means that you cannot use OR operations to close this bit, right? Yes, no. Secondly, this number of elements which have this bit open in array A is odd. So if the number of elements that have this particular bit open is odd, and there is no way that you can close this bit using OR operations, then this particular bit will always be open in the XOR result, final XOR result. So in that case only, you will add this bit, that is 2 to the power this bit, to your minimum XOR when you're calculating minimum XOR. And what is maximum XOR? Maximum XOR is nothing but the initial XOR itself. So this is the case of n is even, when n is even. Is it clear? Yes, no, anything? Okay, you can, like, I'm only saying 1-2% in the chat. If you're having doubt, unmute yourself. Otherwise, your doubt will, like, it won't be cleared.
Yeah, can you repeat once, like, in some example given by giving?
Okay, yeah, I'll take some example. So first, let me explain this minimum XOR part again. See, let's suppose these are from 1 to 30. These are the bits. Finally, these bits, like, if this bit is 1, then, like, I'm trying to calculate what is the minimum XOR possible. So first I'll check whether or not, like, whether this bit will be open in my minimum XOR or will be closed in my minimum XOR. So I'm just checking whether it's ever possible to close this bit, and if it is not, like, it's never possible for me to close this bit will finally come in my minimum XOR. And how it will come? Like, I will add 2 to the power this bit in my minimum XOR, right? So how, like, when will this bit always be present in my minimum XOR? When, first of all, the number of times this bit comes in my array A, number of times this bit comes in my array A is odd, and there is no way that I can close this bit. So what does it mean that I can never close this bit? It simply means that there is no B such that, like, if B is B, there is no B which is having this bit set, BJ which is having this bit set. Why? If there was at least one BJ which was having this bit set, then I would have simply taken OR with that B. So what would have happened? This bit would have closed, right? Because it will finally be open in every element of array A, and when I take XOR, it will finally get closed, right? It will get unset. Is it making sense? Yes, no? Is it making sense? Okay, so now let's take an example. So, no, okay, first let's cover the, okay, instead of, okay, I'll take example only. So let's say you have that thing only, 0, 1, 1. These are the 4 elements. Suppose these are the elements, okay? And so, like I said, maximum XOR that you can get is, you take initial XOR. Initial XOR is what? 1, 0, 0, right? So this is 4, maximum value that you can. And let's suppose you have 2 elements in your array B. One is this, and the second one is this. So, like I said, what is the minimum XOR that is possible? So first, I'll check the initial XOR is this thing, right? So first I'll check if this bit is coming odd number of times, yes, but I have an array which I have an element in array B which is having this bit set. So what I'll do, I'll pick this element, I'll take OR with each and every element. So my modified values will be this thing, 101, 111, 110, 101. And now if I take XOR of these values, my first bit will be unset, right? So this is why I'm saying that if there is at least one element in array B which is having this bit set, then I can unset this bit in final XOR. Then this thing, since there is also an element that I can use, and anyway, this bit is coming even number of times. So this will be 0 only, and the last bit, I don't have any element which can unset it, but the number of times this bit is occurring is like this bit is occurring odd number of times, right? This bit is occurring 1, 1, 1, 3 times, and there is no element in B which can unset this. So this will be set only. So this is the minimum XOR, this is the maximum XOR. Is it clear? Is it clear now? So is it clear to everyone, or is still someone having any doubt? Can you unmute yourself and let me know whether or not it's clear?
Yes, sir, clear.
Okay. So now let's take, see, this was n when n is even. Now let's pick up the case when n is odd. So we just reverse the thing, right? Now, if we have odd elements and we are taking OR with any bj, so what will happen? Now this, if there are some bits set in bj, those bits will become set in each and every element. So that bit will finally be always set in the final XOR, right? If bj has a set bit, that bit will always be like set in all of those elements if I take OR operation, and that set bit, like that bit will also be set in my final XOR. So here I can only set some bit using OR operations. I can never unset. So first of all, what will, now in this case, what will be the minimum XOR? Can anyone tell me? What will be the minimum XOR in this case? Yes, it will be the initial XOR. Like previously, like we were not able to open any bits. In this case, we are not able to close any bits. So this will be initial XOR only. And now, like we did last time, how to find the maximum XOR, we will just check whether or not we can open this bit. So how we can open this bit? Either if the bit is occurring odd number of times initially only in the array A, or there is at least one element which in array B, which is having this bit set. So if any of these two conditions are true, we can set this bit as 1 in our final XOR. So in maximum XOR, we will add 2 to the power this bit. Is it clear? So this is for odd cases. We have already covered even cases, and this is how we can solve this problem.
Sir, can you please read the chat?
Okay, what?
Can you please answer my question that I have posted in the chat?
Okay. What is your name?
Sir Harsh.
Okay. So your question is,
Second
actually
last.
the order won't matter. Why will the order matter? Like, why do you think order will matter? See, in this problem, if we like anyway order, like first you will do all the OR operations and then you will take XOR.
So what if I take XOR for all the elements and then take OR with any BI?
So like finally you have to minimize and maximize XOR, right? Once
Yeah,
you've
first I
calculated
take
then you
the XOR
array
and
element.
then check.
Like what you are doing basically, first you are calculating the XOR and then you are changing the array elements. Why are you changing the array elements after calculating the XOR? First you will change the array elements and then you'll calculate the XOR, right? You have to minimize.
So that's what I'm asking. That does it change the answer in any way? Like we know that
You have
bitwise
already
operators
calculated
are
the answer.
associative.
You have already calculated the answer and then you are changing the input.
So
So
but bitwise operators are associative, so order doesn't matter. No?
like okay, I didn't understand what.
So bitwise operators are
First,
associative.
first you have to apply OR operations, like all the OR operations that you want to do, and then once you have finally come up with an array that you prefer, you find the XOR of it. So this way you have to find what is the minimum XOR possible and maximum XOR possible.
So but I did that way and the answer, sir,
Like
it was
okay,
also
you are first calculating, like you are saying I'll first calculate XOR and then I'll do OR operations.
yeah.
So
The
you'll like what will you will first calculate initial XOR and then you will change
initial
these array
OR
elements. Yes, and then
and
you'll change these array elements.
no, I took
Okay,
XOR
you
for
will
all
do
the
OR with
elements.
this. Yes. That way also you can calculate your answer. You will, if you're performing your OR operation directly on this initial XOR.
Yeah, because BI is same for all the elements in each
Yes,
operation.
I misunderstood. I thought that you were changing these elements.
So yeah, so the answer won't change, no? Because associative
Yes,
will
yes, you can
come.
calculate. Probably there was an implementation mistake. You can calculate it like that also. Like you'll have to change it. You'll have to implement it correctly, but it should work, I think.
Yeah, it was.
Okay. So I'll show you the implementation. Okay. So first I'm taking n and m as input. Then I'm taking array A and B as input. So this is the initial XOR of all the array elements in array A. Then if n is even, like I said, I cannot unset, like I cannot set a bit. I can only unset a bit. So my maximum value, maximum XOR will be initial XOR only, and I have to calculate the minimum XOR. So how to calculate the minimum XOR? First, like for each and every bit, this is CA and CB. This is number of elements, count of elements in array A which have this bit open, and count of elements in array B which have this current bit open. This is how I counted those. And if there is odd number of elements, there are odd number of elements in array A which have this bit open, and there is no element in array B which has this bit open. So I cannot close this bit. This bit will always be set in the final XOR. So that's why I'm adding this to my minimum XOR value. That is this val variable. So I'll add this to val, and finally I can print my val and initial XOR. This is my maximum XOR. This is my minimum XOR. So if n is odd, then like I said, I can only set a bit. I cannot unset a bit. So in that case, my initial XOR will always work as my minimum XOR. Now, how to calculate the maximum XOR? For each and every bit, again, count how many elements are having this current set bit, this bit, current bit as set in array A, and count all the elements in array B, which are having the current bit as set. So once you do this, you can just check if there are odd number of elements in array A that are having the current bit set, or there is at least one element in array B which is having the current bit set. Then you can add the current bit value to your val, and val is nothing but your maximum XOR possible. Is it okay? Yes, no?
Yes, it is clear. I have one doubt. Like if here you are again traversing for like its set bit is even or odd. So we have already calculated the initial XOR. So can we take the like if bit is set, then we will mark it as like this is odd number of set bit will come.
Yeah, I get your intuition. Yeah, basically you don't actually have to again and again iterate like this. You can calculate the OR result initially, and then you can look at that result only directly. So yeah, it's also possible, because what we are doing here, we are again and again iterating. You can just calculate the final OR value also here, and using that also you can work.
Okay.
Let's go to the next problem. So the next problem is this. In this problem, we are given that there are two integers n and k, and we are also given an array of integers a1 to an of size n. It is known that for all I from 1 to n, all the values of array A are between 1 to k. Now, we can define a two-dimensional array B of size n cross n as follows. So this is Bij will be the minimum of Ai and Aj, and we represent array B as a square, which is upper left cell in B11, and rows are numbered from top to bottom, and the columns are numbered from left to right. So we need to find, for each value from 1 to k, we need to find the smallest rectangle in array B containing all the cells of this like value Bij basically. So when Bij is equals to k, we need to find all those cells should be inside this rectangle, and we have to find the smallest such rectangle. So finally, for each k, we have to output the sum of the width and height of this rectangle. So first of all, how many people were able to solve this problem? Okay, I'll explain the problem itself first. Let's suppose the values that we have is 1, 2, 3, and 4. So the array, the first will make a grid. So assume 3 here, 1 here, 2 here, and 4 here. 3, 1, 2, 4. So now I'll just fill the elements with minimum of the values present here and here. So this is 3, this is 1, this is 2, and this is 4. So this will be 1 only, this will be 1 only. This will be 2, this will be 2, this will be 3, and this will be 3. So if you paid attention how I filled this, like basically, okay, what we have to print, see, for 1, what is the square, what is the rectangle in which 1 is coming, like all the ones, 1 cells are coming. Basically for 1, this is the square, right? This is the smallest square in which every one cell with 1, like cell numbered 1 is coming, right? You cannot have a square or rectangle less than this size. So similarly for, let's say, 2 also. So for 2, these are the 2s, right? So for 2 also, there will be this square only, like this rectangle. So basically, if you pay attention how I filled these values, see, if 1 is coming here, see, 1 is the smallest value, right? 1 is the smallest value. So first of all, if 1 is coming like this, these are your rows, right? Right now, this is your row, these are all the rows which are currently part of your, let's say initially you have all of these rows and you have all of these columns. So if I pick up the smallest number in my array, which is 1, I definitely know that it will cover all the columns from here to here and all the rows from here to here. Yes, no, anything? Is this making sense? If I pick the smallest element in my array, which is 1, it will always cover all the rows that are currently available and all the columns also. So what will be my answer? It will be nothing but rows plus columns for this. Columns, rows plus columns, right? Why is someone writing rows plus columns into 2? Why into 2? It will be simply rows plus columns, right? Okay. Yeah, I'll come to that part later. It is actually rows into 2 only, but yeah, I'll come to that part. So rows plus columns. Now let's say, now what will happen after this? This, I can assume that this row is no longer existing. This row is no longer, this column is no longer existing. This row is no longer existing. So what was here? I was having 3 here, right? So now let's come to 2. For 2, like, okay, this thing is not existing, this thing is not existing. So now 2 will, this is not existing. Now 2 will also take every column from here to here. So basically, for number of columns taken by 2 will be nothing but, like, this is 2 and this is, like, this is taken by 2 and this is taken by 2. So it will be nothing but smallest, like initially, like what I wrote rows plus columns. So actually it is not rows plus columns. It is like, actually it is number of rows plus number of columns, but how to write it using this thing? It is nothing but smallest row that is available to me right now, like, and the biggest row that is currently available minus +1, and same thing with the columns, right? Biggest column minus smallest column value, or you can write it as rightmost column minus leftmost column +1, right? So for 2, this is the smallest row, this is the maximum row, this is the leftmost column, and this is the rightmost column. So for this case, for 2 also, the value will be 4 plus 4, which is 8, right? Yes, no, anything? Clear to everyone? Okay. So now let's see, okay, all the things that are gone, that this thing is gone. This part, like these two rows are not available to me. This is not available to me. Okay. So this is not available to me and this is not available to me. Now let's come to 3. So once I come to 3, so this is 3. Okay. So this is a 3 here, there's a 3 here, there's a 3 here. So again, I'll do the same formula, and actually in this formula still the values will be same only. Highest column, lowest column, like leftmost, rightmost column. And again, I will get 4 plus 4 as 8, right? Yes, no? Again, I'll get the same value for 3 also, right? Because still the lowest column, like the leftmost column, rightmost column, earliest row, that is the topmost row, and the bottommost row are still same. But after this point, like 3 is also not available now. So now this is not, this row and this column is now removed. Now for 4, now let's look out for 4. So for 4, rightmost column and leftmost column are same. So that will, like, this will cut itself. We'll have 1 plus 1, which is 2. And for all the others, I will have 8, right? Yes, no? Is it making sense? So, okay, let's look at one more. Now we'll just quickly one more time go over this. One more time we'll go over a test case, and then after that, you yourself will be able to write the code for this problem. Let's pick up the 5th test case. The 5th test case is 5, 3. Like you'll get an idea what is happening. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. This is the grid that is initially given. 1, 2, 3, 2, 1. So let's quickly fill up these values. This is 1. This everything will be 1 here. 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 Everything will be 2 here, 2 here, 2 here, 2 here, and 3 here. How I have taken just the, like, this is nothing but minimum of these two values. Okay. So now let's, like I said, first I'll go to the minimum value. Minimum value is 1. Let's try to find the answer. Right now I have all of these columns with me and all of these rows with me. So what is the answer for 1? Can anyone tell me? It is 5 plus 5. Like the minimum row minus minimum row plus 1, maximum column minus minimum column plus 1. After this 1 is no more with me. Like I don't have these rows and columns. For 2, what is the answer? Minimum row minus maximum row. So it is 3 plus 3. Now I don't have these also with me. Like I'll remove all the rows and columns in which 2 was there. So now for 3, what is the answer for 3? For 3, it is 1 plus 1. So first of all, the thing to note is you can just create columns that are available to you right now. Initially, let's make this a set. Initially, you have everything between 1, 2, 3, all the way till 1, 2, 3 till n. And same thing for the rows. So you have 1, 2, 3, all the way up till n. You have these, make this set. So for each value, 1, just find the minimum row and maximum row that is available in your set. You can find it using just like the maximum minimum is available in log n. So you can find that value, just find the difference and add it to your answer for current value. Then remove that particular, like 1 was present at this row, right? And this column. So remove these values from your row and columns. And by the way, you don't have to do this. Like you don't have to actually maintain rows and columns. Why? Because this is simply rows. Always rows set will be equals to column set. Why? Because initially you have added in both the sets, you have added 1 to n, and you're always removing. See, if you're removing 1 from the first column, you're also removing 1 from the first row. If you're removing 1 from the last column, like last row, you're also removing 1 from the last column. So it's just symmetric. So instead of doing both rows and columns, you can just maintain one set, insert every 1 to n in your set. For each value from 1 to k, iterate in this order. Find, first of all, for 1, what will be the answer? Answer will be 2 times maximum value in your set minus minimum value in your set plus 1. Why 2 twice? Because I'm doing this for both rows and columns. Then for all the positions at which 1 was present, remove those values from your set. Is it clear? Is it clear? All the positions. Yes, no. Is it clear to everyone? Or anyone is having any doubt? You can ask me right now. Otherwise,
Can you repeat the set part?
like which set part?
Adding values in the set from 1 to.
So basically, see, if initially this basically means forget about one set. We have two sets. First one is set this and this is a row set. So why basically I need a set? Because I need to quickly find what is the maximum value. I need three things: the maximum value, I need the minimum value, and I quickly want to remove some values from my collection. So what should I use? The basic, like the first thing that comes to our mind is set. So that's why we can make two sets, one for all the rows that are currently present, and the second is for all the columns that are currently present. So initially both sets, rows and columns will have, like this will have all the rows that are present in the grid, and this will have all the columns that are present in the grid. So if I have a minimum, like for 1, I can just find what is the minimum row, like what is the maximum row minus minimum row plus 1. So this will give me the number of rows in the rectangle or the square which will have all the ones. One will be like this, right? Like I have already shown. One will be something like this. Like
From where you are getting this max row and min row?
max row is nothing but maximum value of, like maximum value that is in your row set, and minimum row is nothing but minimum value that is in your currently in your row set, plus maximum that value that is in your columns minus minimum value that is in your columns set plus 1. Once you do this, you can remove this row and this column, like these are no more in your maximum row, like in your row set. So just remove this and again find for 2. What is the value for 2?
Maximum row
Again,
will be all my elements should be the same.
what?
In maximum row, the maximum row is basically the row where all the elements are same.
Maximum row, no, maximum row is currently all the rows that are available. See, after 1, you can just ignore this row, remove this row, this column, this row, and this column. So by default, now the rows and columns that are available to you are only in this part. So that's why the minimum row will have the value 2, maximum row will have the value 4. So now for 2, the number of rows will be 4 minus 2 plus 1, which is 3. Because you have already removed these rows, these 2 rows. Is it clear now?
Yeah.
So like someone asked me, is it clear to that person?
One more thing,
Yeah.
like it's in the set it's inserted like 1 to n,
Yes.
and we are removing the minimum and maximum. So
No, we are
it
removing
will
the positions. We are removing the positions at, like you will go from 1 to k. First, you'll remove all the positions at which 1 is present in your array. So if 1 was present here, and let's say 1, 2, 1, 3. So we'll remove 1 and 3 from your set.
okay, got it.
Okay. So this is clear to everyone, right? Okay, I'll show you the implementation. So this is the implementation. In this, I'm first taking n as input, then I'm taking k as input, then taking array a as input. So like all the positions, this is a vector of vector just for calculating the, like what are all the positions at which 1 is present, what is all like all the positions at which 2 is present. So I'm decreasing it 1 by here because I just wanted to make all the values 0, starting from 0. And in my set, I'm just inserting everything from 0 to n minus 1. Now, how to calculate answer for each value? Currently, I'm finding the answer for 0, like this is 1, like the value 1 in your grid, in your array. So if the current value never appears in your array, then the position for this will have no size. Like the position vector for this value will have no size. So I can simply continue. This will be 0 only, like the value corresponding to this, the answer corresponding to this value will be 0 only. Otherwise, I can calculate my answer for current value as 2 times, like I said, the maximum value in your set minus minimum value in your set plus 1. And then remove each and every position for this current, like all the positions at which this element was appearing, this value is appearing from your set. Finally, you can print your answer vector. This is a vector, not a variable, okay? Is it clear? Yes, no. Is it clear? Okay. So let's go to the next problem. So this is the next problem. In this problem, we are given that we have an array A of n of size n, and initially this is filled with zeros. Now we can have an array of, like, we have an array of integers C of size n, and then initially we also have k coins. Now by paying ci coins, we can add I, like we can add 1 to all the elements of array A from the first position to the ith position. So we can buy ci any number of times, and a purchase is only possible if we can actually, like, if k is more than or equals to ci. We cannot buy if we don't have that many coins, right? So then we have to find the lexicographically largest array A that is possible. So everybody knows what is lexicographically larger, right? If there are two arrays, then of same length, then array A is said to be more than array B if at the first place at which array A and array B differ, array A is having more value. So now this is just input. So we have to find the maximum lexicographically maximum array. Let me explain the problem here once. Initially, we have n elements. Everything is 0. And corresponding to these values, we are given some C0, C1, C2, C3, C4 till Cn. So if we once use this C3 coin, so first of all, initially, if we had k coins, after this operation, we will have k minus C3 coins, right? So once we do this, we will have ones at the prefix of this. After this, we will have zeros, and we will have k minus C3 coins. Again, if we do the same operation at this point, we will have 2s here, and all the other places will have zeros. And now k minus 2c3 coins. Like I'll have these many coins left. So this is how I'll have to find an array which is lexicographically maximum possible. Is it clear? Is the problem statement clear? What about others? Is it clear problem statement? Okay. So now, if this thing is clear, see, first of all, for this position, I can pick up any ci values from this to this place, right? I can pick up any ci value, right? If I want to have a 1 here, if I even pick this value, so eventually, since I'm adding ones to the prefix of this, I can choose any of the ci values from here to here. So in order to make this maximum, let's say if I'm choosing the ith value, how many times I'll get 1 here, I'll get k divided by ci times floored, right? If I'm picking some ci, right? At the first position, I'm talking about the first position. Yes, no, anything? Yes. And now by default, if this is the value that I want to be maximum, what do you think? What should be the CI? In this range, what should be the CI? CI should be the minimum possible value, right? So if this is my array, if this is my array, I'm trying to find what is the maximum number that I can get here. So I'll pick the minimum value from this range, and I can have k by ci here. Similarly, for this part, let's say k dash is the remaining number of points that I have. I'll pick the minimum number of value from here, and I'll update this value by k dash by ci. Now there is only one more thing that we need to take care of. See, once you do some operation here, the number of coins initially were k. You were able to do k by ci operations here, right? Okay, let's write this as minimum c. So minimum c is nothing but min c is minimum of all the c values, I from 0 to n minus 1, all ci values. Okay, so this is your minimum c. So once you know that you can have this much value here, how many coins would have been used? How many coins would have been used? Can someone tell me? If this is the value that you're getting here, it will be like, you can either find it, okay, the coins left will be k divided by c. So these are the points that you're getting, and each point you're getting using min c. So this is actually floor division. This is floor division, and divide this by min c. Yes? No? Anything? Right?
Can you explain this part?
So this is basically, these are the number of ones that, like, the value that you can get here. These are the number of operations that you will perform. If you have k coins, minimum c is the minimum of this range. So this is the number of operations that you will perform. So you will get that this value. This is basically k divided by min c. This is the value that you'll get at the first place. And for each operation, you are paying these many coins. So that's why these are the number of operations. This is the number of coins that you're paying. Initially, you had this much coins. So this is the value. That is the number of coins that is left with to you, right? Let's say this is k dash, right?
Yes.
So you have k dash coins here. So now we just need to check one thing for this problem. If in case, instead of having all the k coins used up here like this, what if I calculate another value, min c dash, and this is nothing but minimum of I from 0 to n. Okay, this is not 0. Okay, so now instead of having just that value, I'll calculate minimum of I from 1 to, that is just skipping this number, minimum of this range. So minimum of I from 1 to n minus 1 ci. Okay, this is min c dash. What if I'm getting like this value, like this is the maximum that you can get at this value. We'll say we want lexicographically maximum. So we'll try to maximum all of these values. Like this will have the most maximum priority. We'll have to maximize this first, then this, then this, then this, right? So first I've already maximized this. Now, in order to maximize this, I'll just check if I can somehow keep this value as itself. Like I have already calculated this value. This is the maximum value possible, right? So if I can already somehow keep this value as itself, but I can increase this value also. So initially, like right now I'm having k dash coins, but let's try to increase these coins. How I can increase these coins? K dash, I'll add some x coins, x times I'll add coins from this. Like I was use like C of I minus 1. Okay, this is not C of I minus 1. This is min C. I was using min C coins in each operation there, right? I'm doing x operations less. Like these are the number of operations that I was doing here, right? So I'm doing x operations less. So I will get min C coins left after this point. So total number of coins at second place will be this. And if I divide this by min C dash, if this complete value turns out to be, if this value turns out to be more than or equals to, like it won't be actually more than, but it can be equals to x itself. So what does this mean? Add these many coins to from the first, like instead of doing all of these x operations at the first place, don't do them at the first place. So you will have these many coins left for the second place. And if you divide this by min C dash, you'll anyway get these x like x value from to each of these places. So this finally, like first I had k divided like these many operations. Then I said I'll be doing x operations less so that the second place can get this number of coins. And then finally, since I'll be doing these operations and there is a value, if I divide this by min C dash.
So is it floor or seal of k by min C?
Okay, this is floor, this is floor. This is floor. This is also floor. So basically, I said instead of doing these many operations, I'll do x operations less. So you will get these many coins extra at this place, at the second place. After that, what I'll do? So you'll get, instead of getting k dash coins, you will get k dash plus x times min C dash coins, min C, not min C dash, min C coins at the second place. And if you divide this by min C dash is nothing but the minimum value from first place to nth place. From first place to n minus 1th place. If this is more than or equals to k, then anyway, this will again get x added, right? Yes, no, because I'll be doing some operations from this place again. This is min C dash point. So again, this will get 1, right? Like this will get x added. All of these will get x. But now the thing is, this thing will also get x. So I have already maximized this first place. Now I'm trying to maximize the value at second place. Is it clear? Yes, no, anything? Okay, what about others? Is it clear? Yes, no? Now, the thing is, first of all, how to select x? X, we need x to be max as possible. Why? So that we can get the maximum value for the second place, right? So how to do that? We can do that using binary search. Like we'll find the maximum value of x using binary search. And how to find these two values? We can find these values using multiset. Like what is the minimum value that is currently available to me? These values can be found using multiset. So this will be much more clear if I show you the code once. So let me show you the implementation once. So this is the implementation. In this, I'm first taking C as input, array C as input. Then I'm taking array K as input, like not array K, the value K as input. So this is my answer. I don't think this is my final answer. This is my multiset. Multiset is nothing but to know what is the maximum value that is after this point. So initially I'm inserting every value in my multiset. Then what is the answer for the first place? Like I said, it will be nothing but K divided by, this is min C. This multiset dot begin value. This is minimum C value. And the number of coins that are left for the next position is this much. Like I said, this is answer dot back. these are the number of operations I did, and this is the cost for each of those operations, the number of coins used. So I'm decreasing this by k. And now, since I'll be removing this from my multiset, why? Because I'm going to the first position. Now this is no more. This value is no more available to me, C0. So it's better to save the begin value itself. Like this is the min C, initial min C. Now going from 1 to n, what I'll do? First, I'll do binary search and I'll try to find this temp. Temp is nothing but x. What is the maximum value that I can multiply with? Like that is the maximum number of operations that I can skip for the previous position and do them right now. So how to do that? Low is initially 1. High is the number of operations that were done in the last place. And k plus this is the minimum c used for the last operation. So k plus minimum c into mid. Mid is the number of operations I'm trying to skip for the last position. So if I divide this value by the current minimum c, so this is min c dash. So if you divide this by this and you find that this is giving you a value more than mid. So if you're skipping mid number of operations for the last place and you're getting at least mid operations now, so you can just skip those mid operations for the last place, right? So temp will be mid, low will be mid plus 1. Similarly, if this is not true, high will be mid minus 1. Once this is done, you can increase the number of coins for the current place by min c into this temp. That is the number of operations that you are skipping. Then used will be updated right for the further operations. For the next operations, min c will be this thing. That is the current minimum. And you'll insert your answer for the current value will be k divided by, that is the number of coins that you are left with, divided by the minimum c value. You can write this as used also because you have already updated the used value. And then you'll erase the current ci value from your multiset because now this value will no more be available as your one of the possibilities for minimum c values. Then for the next iteration, the number of coins will get decreased by the number of operations that you did at the current place and the number of coins that you were using for each operation. Finally, you can print your answer for like complete array. You can print your complete answer vector. Is it clear? Can someone unmute and tell me, is it clear? Yes, no?
Yes, sir.
Okay, what about others?
There's no one, sir.
Okay, so I think they have left. So anyway, so that's it for today. So hopefully you learned something and thanks for joining. Bye-bye.